Again to Let's Talk Chemistry with Pastor Dan. We're looking at atom size. Atom size is a periodic nature we find in elements, and we can use the periodic chart to help us to identify how this process takes place. Okay, the general rule that we're going to look at in terms of atom size, as we're going down the families, so going down the columns, we're getting bigger. The reason why we're getting bigger is we're at an energy level. So the atom is getting larger and larger and larger. And going across a period, now across a period, we're not adding more energy levels. We're just adding more protons and more electrons. And because those charges are opposites, they're going to begin to suck in. So we're going to get smaller as we go in our periodic chart. So here's what we're saying. Periodic chart, going down, we get larger. Going across, we get smaller. All right. So we're going to make a general rule, though. That general rule will say that while the smallest in its period, the noble gas, the last one in its period, we're going to assume that it's larger than anything above it. Now, occasionally that isn't the case, but to use the periodic chart and make it simple, we're going to make that generalization. All right, so let's take a look at the following elements here. Boron, which is right here, bismuth, which is right here, beryllium, which is right here, berkelium, which is down here, barium, which is over there, and bromine. Now, increasing, we want to go the one that's farthest down, farthest to the left. So we're going to start with the element that's farthest to the right first and work our way down. Those are the elements we'll look at: beryllium, berkelium, bismuth, bromine, boron. If we want the one that's farthest up, farthest to the right, that would be boron. So boron would be my smallest. Next of them, we go back here in the same row. So next would be beryllium. And then going down a level, bromine would be next. And then berkelium, bismuth, and berkelium. Because if you look at bismuth and then berkelium, wait a minute, how do we use these? Well, cerium and luteum fall between lanthanum and hafnium. So lanthanum is bigger than all 14 of these, and all 14 of these are bigger than hafnium. Same thing with the 5F series. Actinium is larger than thorium through lawrencium. So AC is bigger than TH to LR, but TH and LR are bigger than rutherfordium RF. All right, so that's why bismuth would be before, because bismuth would be to the right of this row, but it's berkelium is a row below that, so therefore berkelium would be the largest. Okay, let's try the next one. Tin, strontium, selenium, silicon, samarium, and antimony. Okay, on the periodic chart, there we go. They're all tightly there with strontium. We're going to go again in the decreasing. So we're going to go the one that's farthest down, farthest to the left. So if we look at that list there, the one that's farthest down, farthest to the left, these are all in the same row. So strontium will be my first. Samarium, I messed that one up because samarium's down here. It's below the other ones. So samarium, followed then by strontium. And if we go back to the list we have there, tin and antimony would be in the same row. Tin, antimony, and then that means that selenium, and silicon would be the smallest. All right, so let's take a look at these. I want you to try to do the first two. I want you to do the first two in increasing, and then the last one in decreasing. So pause it a second, see what we come up with. All right, so there is the increasing: argon, aluminum, arsenic, silver, gold, and carbon, chromium, cadmium, selenium, curium. Decreasing, we would have neptunium, Nd, Nb, Ni, nickel, and sodium. All right, let's do these last two. Pause it, run through them. I want Ni, Na, N, Nb, and P in decreasing. So the one that's farthest down, farthest to the left, to the farthest up, and farthest to the right. And then for the second one, increasing, farthest up on the right, down the bottom left on the bottom. So take a minute, pause it, try it. So that's that. And that's it. Hopefully that wasn't too bad. Take care. God bless. Have an awesome day.